So second question, second topic, nucleophilic substitution reactions. In the question, I've just given you 4 reactions. In each case, I've told you to assume it's a substitution reaction. I've said SN2 because that's the only mechanism you know. So what we're doing here is we're just substituting the halogen with the appropriate nucleophile. So you need to be able to identify the nucleophiles, and these are a little bit more than you might have been told in your A-level class, but always good to understand. Nucleophiles, anions are nucleophiles. Substances with lone pairs are nucleophiles, although you might remember from the nucleophilicity slide that different species have a different nucleophilicity. But you don't have to worry about that here. You've just got one halogen-alkane and one nucleophile. So the first one, we've got 1 bromobutane. So here's the butane, carbon 1, 2, 3, carbon 4, except of course bromine's attached to the end there, which makes that carbon 1. But anyway, it's that kind of elongated N for butane. And our nucleophile, well, Na plus is just always a spectator ion. So we have OH minus. So we will just substitute bromine for the OH minus. So we go from 1 bromobutane to butan-1-ol alcohols that we will study in 2 modules time. Right, 2-methyl-1-chlorobutane, let's draw that out. Here's the butane, that elongated N, chlorine on the 1 carbon, methyl group on the 2 carbon. Nothing special and enantiomerically about this particular one. What is our nucleophile? Well, lose K plus because this is spectator ion. You're left with Cn minus, the cyanide. A really good nucleophile, so we'll replace the Cl by the Cn. 2-bromo-3-methylbutane. Well, there is 2-bromo-3-methylbutane. Again, you can see a little N of the butane, bromo of the 2, methyl of the 3. But I told you that it is S. Now, that would imply that one of these carbons is stereogenic, and it's carbon 2. Carbon 2 has a bromine, has a methyl, has an isopropyl group, and of course has a hydrogen down there. So, how would we draw this? Well, we need to assign priorities. Bromine's 1. Hydrogen is 4 because that's the highest atomic weight, lowest atomic weight. Here, the carbon of interest, carbon 2, goes to 2 carbons. This carbon's only got 3 hydrogens. This carbon's got 2 carbons on it, so that isopropyl group is the second priority. Methyl is the third priority. Now I need to draw it as S. Okay, so I always like to draw my stereogenic ones tetrahedrally like this, with 2 in the plane, 1 away, 1 coming out at you. If I draw the hydrogen away, then that means that to get S, I just need to arrange my priorities in anti-clockwise order. So putting 1, 2, 3. So this is one way I could draw it. Various other ways you could put the different things on, but you've always got to make sure that they're arranged so when you have the hydrogen going away, you go anti-clockwise as you go bromine, isopropyl, methyl. Or of course, if you draw the hydrogen coming out at you, you would go bromine, isopropyl, methyl, but you'd have to do it clockwise because when it comes out at you, the lowest priority group comes out at you, it flips the rules. Hopefully that wasn't too much. Anyway, the point here is that when you do SN2, the nucleophile attacks from the back. So it's going to come in from the back as the bromine goes away in the front. What is our nucleophile? Well, again, we'll lose the sodium. So we've got OCH3 minus, methoxide anion, very good nucleophile. So that's going to come in from the back. As it comes in from the back, it's going to push the hydrogen to the front, and the bromine's going to go away. So there we are, right there. Okay, we've got the methoxy group, the OCH3 coming in at the back. Now the hydrogens then push certs at the front and the bromine's gone. And if we assign the absolute configuration, we got the oxygen is the best, isopropyl better than methyl, so we're going anti-clockwise. But here now the hydrogen's coming out at us because I pushed it away, I inverted the configuration, so the hydrogen coming out at us. So when we go 1, 2, 3 anti-clockwise with the low priority coming out at us, anti-clockwise is R. Last one, 3-bromo-3-methylpentane. There is the molecule there. Anything weird about it? No. We got methyl and bromine on this carbon 3, but it also has 2 ethyls, so it's not going to have an enantiomer. And what is our nucleophile? we'll lose the Na+. The nucleophile is the very useful iodide, so we'll just replace bromide by iodide. So there we are, 4 SN2 reactions predict the products.